Hello. This is Math 320, the second week. And for this topic, we're covering variability. Let's jump right in. All right, so what are we talking about today? We're talking about variability, why we need it, what is it, when is it used, and how do you compute it? See here, there's a note here that this recording is linked here. So of course you would know that because you have already clicked on it. And I'll try to use this same structure. Why do we need it? What is it? When is it used? And how do you compute it for each of the lecture? Because that way we can make it all uniform. Okay, why do we need it? So last week we covered measures of central tendency. These are based, and that was basically the mean, the median, and the mode. So just how do you just take a large amount of data and distill it into a single number? And the mean, the median, and the mode is those are numbers that tells whoever you're presenting the data to what's the central number that captures everything. Like, if you have a sample of 100 people with different ages, what's the mean age or the average age of the sample? What you don't know from the mean or the median or the mode is how much variability there is in your data set. You don't know whether a lot of people kind of fall around the same mean age or people had age spread throughout a large range. So to look at a example of this, look at the bottom right figure and imagine this is two data sets. The first data set here is on the left side, and the second data set is on the right side. So you can imagine the x-axis goes from 0 to 100. Imagine that's ages. And the y-axis goes from 0 to 50. Imagine this is the number of people. Frequency is the number of people. Here you look at 50 within the first data set. At the age of 50, there's around like 40 something people who are age 50 in this data set. And at the age of 60, there are like 9 or so people who had age 60 in this data set. So here the mean age is 50, and you look in the second data set, the mean age is 50 as well, and the number is on top of here. And how you know the mean age is 50 is basically you split this data in half. Where's the middle point? The middle point here is 50, and the middle point here is 50. So even though both of these data sets have the same mean age, they're very different, right? This one's everything is all clustered in the middle here, and where this one is all spread throughout. So this difference in how far things are spread out or clustered together, that's what's considered the variability. The first one has a lot more variability. Variability means the age just varies a lot more. The first one has a lot less variability. Most people in the 50, and the youngest person is probably like 37, and the oldest person here is probably like 67. So so there's not a lot of variability because everybody is adult from late 30s to late 60s. Whereas in the second data set, there's a lot more variability because the age range is from 2 to 97. That's what it looks like. And so this is a sample of children, infants, and adults. So you can say the age varies a lot more in the second one. So the mean, the median, and the mode won't tell you how much variability you have in your data set. I'll just give you one number of what the mean is. But there's a number for the variability, and that's what we're covering today. And so usually when you're presenting a data set or when you're talking about a variable to an audience, you want to present both this measure of central tendency and a measure of variability. And here's the formal definition of variability. Variability provides a quantitative measure of the degree to which scores are spread out or clustered together. And this is the example that we just went through. All right, there are three main measures of variability. There's the range, the standard deviation, or SD for short, and the variance. I will go through the definitions for each of these. The range is basically the distance covered by the scores in your variable. So the lowest point to the highest point. And the range is very common when you're describing a data set. For example, if we're looking at the age again, the age data, like in the previous slide. The range for the first age range for the first one was 30 something and to something 60 something, and the age range for the second data set was from 2 to 97. Standard deviation. Another thing about the range is that it's very useful for describing data, not usually used in the computation of statistics, but useful for describing data. And the value can be negative or positive. Positive does not have a T. Fix that. Right, the standard deviation, or the SD. The definition is the average distance from the mean of a set of scores in the variable. Basically, this just means whether the scores are clustered very closely together around the mean or they're spread far apart around the mean. So if they're clustered very closely together, the standard deviation is small. If they're spread apart very far from the mean, the standard deviation is large. Standard deviation is a very common way to describe the variable, and it can be negative or positive. If the standard deviation is positive, it's to the right of the mean. If it's negative, it's to the left of the mean. I don't know if this means right based on the way you're looking at the camera. I don't know if it's flipped around, but this is to my right, this is to my left. Okay. So standard deviation is it's not common to use that in computations. It's usually more to use to describe the variable. The variance, that's a more computation friendly. The variance is the average squared distance from the mean. Basically, you just take the standard deviation and you square it, and then you have the variance. And the reason why we use it more often in computing the statistics is because it's a positive number. Standard deviation can be negative or positive, but the variance is always positive. And the reason for that is since the variance is just, you get it by taking the standard deviation and squaring it. Anytime the standard deviation is negative, once you square it, it becomes a positive number. So the variance is always a positive number. That's why it says it could only be positive. Right. All right, so here are some examples of, let me move my picture, of the three measures of variability. Again, we have the two data set presented in a histogram form. So this is a histogram. So the range here, the first data set is around 37 to 68. So again, 37 around this mark, just by eyeballing it, looks like 37. 68 around this mark, looks like 68 by eyeballing it. And the second data set, the range from 3 to 97 years old. Again, looks like 3, looks like 97. The standard deviation is, it's given here. Usually you compute it, but the standard deviation is, I just figured it out by eyeballing it, but usually you do want to compute it precisely. But standard deviation for the first one is, you're basically, the way I eyeball it is by looking at where do 68% of the scores fall into. So it's about 5 years old under and over the mean. So the mean here is 50. 5 years old under would be around 45 right here. 5 years old over would be around 55. So looks like about 68% of the scores fall within one standard deviation. So that's a helpful thing about standard deviation, because usually we'll learn about this later in future and future lectures. But standard deviation is really helpful for helping the audience know how much of the sample of the participants in your sample fall within a certain range. And if it's within one standard deviation, then that's 68% of the participants are within that range. All right, second data set looks like 68% of the sample falls within 15 years of age from the mean, from 50. So that means about from 35 to 65, so about 68% of the sample falls between the ages of 35 to 65, so around here. And we'll revisit the standard deviation many times, so it doesn't make sense now, it will later. The variance is just, again, the standard deviation squared. So if the standard deviation of the first sample is 5, the variance is 5 squared, which is 25. If the standard deviation of the second sample is 15, the variance is 15 squared to 25. Okay. how do you compute the range? So the range is very straightforward. You take the highest value of X minus the lowest value, and then you get the range. So here's another example. Pretend you have a data set with blood glucose reading from 10 people, and the readings were 99, 88, 106, 150, 125, 113, 90, 89, 94, 130. What is the range? The solution is the range is the highest reading minus the lowest reading. So the highest reading here is 150 and the lowest reading is 88 right here. So you minus that, you get 62. And the way you would, you write this up for the report and you want to report the range, you would say the blood glucose reading in this variable ranges from 88 to 150, spanning 62 points. So let's do a practice. You see here, I linked two files. One is the exercise sheet and one is the answer sheet. So the exercise sheet is for us all to practice along with this video. Right. So here we have a practice data set. We have here 29 participants. And the way you know is because there's 30 rows here and you minus one for the heading, you have 29 participants. Or you can look down here and you can see that the count is 29. So that's the first column is the participant ID. The second column is the salary for each participant. So the first person makes $60,000. The second person makes $20,000. The third person makes $0. Maybe they're a student, maybe they're employed, who knows? And the next person makes 30,000. So just a variety of salaries here. So how do you compute the range? Remember the range is X max minus X minimum. Okay, so X max, the range was X max minus X min, and you get, so what's X max and what's X min? Well, you can just look down here to see which is highest and which is lowest, but the easiest way to do this is just highlight the whole row, click on this bottom shortcut here, and look at the max and the min. See, the max is 400,000, the min is 0. So in 400,000, it's 400,000, yeah, minus 0, you get 400,000. So the way you would describe this is the salary variable range from $0 to $400,000, spanning $100,000. All right, easy peasy. All right, what's next? All right, that's the range. Now the standard deviation. This one is the most difficult to compute of all three measures of variability. So we'll work through this step by step. So the formula for the standard deviation is this, which is a lot. And you see here, this is the legend for what each of these symbols mean. SD is standard deviation, SQRT square root. This sigma this means the sum. X is each X score. M is the mean of all the X values together. This is the squared. N is the number of scores in the sample or the sample size. So the best way to do this is by taking it once, each step at a time. So I'm going to show us demonstrate how to do this by hand and demonstrate how to do it using the Google function method. So you know both ways. Okay, so what I'm going to do is I'm going to go ahead and copy these steps and paste it here. Near the section that says compute standard deviation of salary variable manual method. This is too big, so let's make this. And so here, each of steps, there's a section to input the values that we need to get. So I'm going to go ahead and bold that so we can reference it easily. This value doesn't need to be here. Okay, so first step, identify the mean value for the x variable. Where's the x variable? We're looking at salary, right? So what is the mean for the salary? Highlight, go ahead, I could go ahead and highlight all of them or select all of them. Look here and look at what the mean is, which is the average, this number, 46827. We'll put that here, 46827. That was right. 46827, 46827. Okay, now we have to identify the n value, the number of participants in our sample. And so again, I think it was 29, but we'll highlight it all just to confirm. The count is 29, yes. N is 29. All right, now we have to compute the sum of squares. And I'll talk about what that means in just a minute, but let's look at these steps, for these sub-steps for the sum of squares. First, we have to create a new column to compute the mean deviation. The mean deviation is called, actually, this is called the x deviation. I'll change this in the lecture too. Okay. Compute the x deviation. X deviation is how x deviates from the mean. So meaning when you basically just subtract the x from the mean for each one of these x values. So here we'll use the symbol that's included here, x minus m, x minus m. So each of these are the x, and the m is, what's the mean here? 46827. So how you want to do this is by pressing equal sign, clicking the x, putting minus, and typing in the mean value, which is 46827. And hit enter. And anytime you put an equal sign at the beginning of the cell like that, it tells Google that you're doing a computation or you're entering a function. Here, Google has this handy suggested autofill, meaning they'll put that equation in for the rest of the column and ask if you want that. So we do want that. All right, so that means each of these values here is basically this value minus the mean. So this one's a negative number because this value is lower than the mean, but the value is higher than the mean, then it's a positive number. 100,000 minus 46827, you get 53173. Okay, perfect. So this step is done. The next step, create another new column to square each of the x deviation. So let's go ahead and use this symbol here. X minus m squared. Okay, so here this just means take this value and square it. So we could do that easily with the equation. Again, equal sign, click on this value, put the hat sign and put a 2. That means square it. Hit enter. And you see here, that's the answer here. When you square this number, you get 173,527,929. Hit enter to apply it. And again, Google does this helpful feature of filling in the formula for the rest of the rows. I want that, so I'll click the check mark. Here we go. So each of these values is just the square of this value. So the negative becomes positive and the positive stays positive. Because every time you square a positive, you get a positive. Every time you square a negative, you get a positive. Okay, what's the next step? Now we have to add up the values in the x squared deviation column. This is the x squared deviation column. And you call this a sum of squares, the single value, because you're summing the squares. Each of these are squares, and you're taking the sum of all of them. So again, we can find the sum by just selecting all these values and looking at what the sum is, which is like this giant number that it's going to be, if I try to type it, I'm going to make a mistake. So what I'm going to do instead is use the equation to calculate it for me. I put equal sign, I type sum, and you see here, this is what this Google function does. It's the sum of a series of numbers and or cells. I click on this, And then I highlight all the things I want to sum up. There you go. Perfect. I hit enter and I get this really large number. I'll copy this number and I'll put it here in the sum of squares. Nice. All right, final step. Now plug the mean, the n, and the sum of square values into this formula. So easiest way to do that is copy this formula, paste it on the right side here, and then just plug in the rest. Looking at the sum of squares, what is the sum of square value? It's this large number. So I'll copy this, and now replace SS with this value. And now what is the n? The n is 29, remember, that's the sample size. So I'll delete n, put it in, right? So now you don't have to do this by hand. You can just copy it, excuse me, and put it in a Google search bar, and it'll do it for you. This is the value you get, 18161. Let's copy that. And that's your answer. Of course, and then that's the standard deviation. So I'll just copy and paste it here. It's the same. Another way to compute this formula without going to Google is just by copying this formula and click on any cell, put equal sign. So you're telling Google that you want to compute something. If you let's look at that again. See, if you see the cursor, just like a regular cursor, once you put an equal sign, it has this little, like, I don't know what you call this, like a bucket looking thing. It's letting Google is ready to compute something for you. So paste the formula and hit enter, and you get 78101. See, the same as before. So same thing, whether you do it in a Google search bar or you do it in the sheet. That's your standard deviation. That was a ton of work. So usually people don't calculate the standard deviation by hand. I just want to do it here for pedagogical reasons. And just so you know, maybe you're at a party or something and you really want to impress your friends by calculating standard deviation by hand, you could go ahead and whip this out. But usually when you're using some type of software or doing data analysis, software will just give you the standard deviation because it has this, it can do this easily. So let's look at how the software does this. So this is the Google function method. So for estimating the standard deviation, what you do is you go into any cell and you copy and paste this, and you replace the xx with your own x values. So do this, paste the formula. Oh, that's not right. Double click on it first. There it is, and delete xxxx and replace it with my x value. This is the x value. Then hit enter. And what did it give me right here? Let me make this alignment right. 78101.61. That's the exact same number we got before when we did by hand. See, so much easier when Google function does it. So what Google function means is that, see, when you double click on this, you put the equal sign and you put some word to call up the function to tell Google, I want to use this function. And this is a standard deviation function. And the function is just an algorithm or equations that Google has built in already. So when you do this, it automatically applies their equation. In this case, the standard deviation equation to this column. Oh, it's getting dry. This is actually the second time I'm recording this lecture. The first time I had my AirPods in my pocket and I didn't realize that, and it was connected to my computer. And so my computer's audio and mic was in my pocket where the AirPods were. So none of the audio got recorded. So the whole video was just me talking without any sound. So this is my second time recording it. So in any case, Google function is nothing magical. It's basically just what we did up here built in already. So all these steps we did to compute the standard deviation. Basically, the standard deviation Google function is just all these steps that we did that they already built in. So in essence, you know how to build a Google function once you know how to build all these steps. You just have to know how to code it into the software. In any case, most times your standard deviation to get it, you just compute it by using a Google function or whatever feature the software has that you're using. Okay, next step. How do you compute the variance? Remember, the variance is very straightforward. Once you have the standard deviation, the variance is just the square of the standard deviation. So for example, if the standard deviation is 60.43, the variance is 60.43 squared, you get this number, 3,651.78. All right, so let's go ahead and do this in Google Sheets. We're going to do it by hand, and we're going to do it by the Google function as well. Let's compute the variance of the salary variable. Okay, so remember the variance is, let's do the form. The variance is SD squared. That's a formula. So let's have Google compute this for us using the formula method. Equal sign. Here we have the little bucket again, indicating that we're doing our equation. This is the standard deviation, right? 78101.61. And we put the hat, 2, square it, and we get this large number. How do you compute it using Google functions? Let's see. Copy this. Actually, let's highlight this. Then replace x with your x variables. Right, delete this and paste it. And remove x and put in the x variable. So enter. And here we go. There is your variance. See here, it matches up this almost exactly. There's a few digits off just because rounding error, I think. So yeah, it's probably because of rounding error. Variance of a sample. Yeah, that's right. Okay, so numbers pretty much is very similar when you're computing when you compute it by hand or you use a Google function. What the Google function is actually doing is it first takes all these values, it computes the standard deviation, and then it squares it. So it does it all in the background, so you don't have to worry about it. All right, so now you know how to compute the variability of a variable or a data set. We talked about the range, which is the minimum to maximum, the standard deviation, and the variance. So we'll do some more practice problems in class together. See you soon. Okay, stop this.